actually the mantle about 100 kilometers below us. So if I was going to drill down here, I'd have to go 60 miles or 100 kilometers, and I would actually hit the Pacific plate below us. There's lots of earthquakes right along that because these plates are 100 kilometers thick, one plate going under the other plate. So as you have 200-kilometer thick plates colliding, you get lots of earthquakes. So earthquakes occur all the time. If you look downstairs down below in the interpretive center, you'll see a lot of the damage associated with earthquakes around here. Usually they have big earthquakes before the eruptions. They're not as much associated with plate movement, but they're associated with the magma actually coming up towards the surface. Whenever you have subduction zones, you have andesitic volcanism. The andesites can erupt two different ways. You can either have lava flows or have pyroclastics. Whereas if you have like basaltic eruptions in Hawaii, it's all lava flows. They don't get the pyroclastics, it's just lava, lava, more lava, lava, lava. Yeah, I'll point those out in a second. They're the violent volcanic eruptions. With the basalt, because it's higher temperature and it's thinner, it just passively comes out onto the surface, it bubbles and stuff like that, but it just flows out in thin layers. If you look at a Hawaiian volcano, it's very low sloping. They call it a shield volcano. It'll look something like this. It doesn't even look like a volcano unless you get to the crater. When you get to the crater, it'll be something like this, not quite this big, but it will be very low sloping, and you'll see thousands and thousands of lava flow, and they're all just black layers one after another. These guys are different because all this water is coming from the dehydrated crust. As that water comes up into the mantle, it causes the mantle to start to melt. As the mantle melts, it produces these different lava compositions called andesites. They're named after the Andes Mountains. The Andes Mountains are a continuation of the same subduction zone. The same subduction zone continues north all the way up into the Cascades, Mount St. Helens, Mount Rainier, all the way up into the Aleutians, through Alaska, and wraps all the way around in a chain of volcanoes we call the
Ring of
Fire that surrounds the Pacific Ocean. The Pacific Ocean is a shrinking ocean. Now all the plates, the continental plates, are moving towards the center of the Pacific Ocean. As it does, it makes the Pacific smaller and smaller due to the subduction as this oceanic crust goes below the other continental crust, in this case right here. As you get this water-rich magma being produced in the mantle, it moves up towards the surface. These magmas have up anywhere from 3 to 5% dissolved water. It's in solution, it's under pressure. So we're used to water in solution, that's what water is. However, at high temperatures, water wants to be a gas, okay? It doesn't want to be a liquid. We're talking temperatures of the magma about 1200, 1300 degrees Celsius below us right here. So that's way below, or way above the melting temperature of water. What's the vaporization or steam temperature that you convert water to steam at?
100 degrees Celsius.
So we're 10, 13 times higher temperature than that. Why does it stay as water below us if it's that hot?
Under pressure.
The pressure of the overlying rock. So as long as you have these rocks on top, that magma and that water stay together. As this magma moves up, this magma, the andesite, is much thicker and more viscous. It can't just allow the steam to bubble out. So what happens when it gets near to the surface, if all of a sudden it moves up too quick, it's ba-boom. That water vapor in there expands several hundred times its original size. So if you start with 5% water in a magma, you can imagine a block with 5%, 1/20th of the water, and you expand that several hundred times its volume, it's now taking up more room than all of the magma to begin with, several times more of that, and that causes the rapid expansion. Some of the magma comes up actually as a little more mafic or rich in iron and magnesium, higher temperature and hotter, and it will form lava flows. If you look over on this wall right over here, you can see a good comparison. These layers are the cliff faces. You see 1, 2, 3 through there. You can see another one right there. These, matter of fact, you can probably count about 10 of them there. 1, 2, 3, I see 4, 5, 6. These are the lava flows. In between them, the ones that form the slope, you can see it really good. The white stuff over here, that's the pyroclastics. That's the ash that erupts out of there. This is a classic composite volcano. It means it's a mixture, or also called a stratovolcano, of ash and lava. So sometimes you get lava, sometimes you get ash. The 1917 eruption caused, there used to be a crater lake in here, which would be really beautiful if you could see it, you know, back in time. That crater lake was blasted out, and probably there was lots of fractures along the side, and it actually leaked the water out, probably steamed a lot of it, boiled it out. This was actually a small eruption. This is not the eruption that caused a lot of the damage to San Salvador. Most of the city, or a large portion of the city of San Salvador, was messed up or destroyed, not only due to the eruption of all the ash coming down, but also due to what? Anybody look at the pictures down there? The earthquakes. So they had very strong earthquakes, and then they had volcanic eruptions on top of that. Where most of the lava and ash came out of was not here, but along fractures along the side. You can imagine big liquid, like a lava lamp, big blob moving up towards the surface. Okay, it's called fracture and break up the rocks in Mount St. Helens. It caused a massive landslide on the side. A big side of the volcano broke off and slid down, and that blew out the whole side of the volcano. Here, instead, we seem to have massive fractures along the sides, so as it pushes it up, it fractures, and if it can get out through those fractures easier than it can get out through here, it erupts there. This tells you this is probably not an active conduit or pipe coming up here, otherwise you would see all the gases coming out of there. You would see the fumaroles there. Lots of sulfur-rich steam coming through there, and you see none of that. So that means this thing is more or less pumped. It's filled with cold, solid lava right now. However, the point is, this could easily be the center of a next eruption. Why? Down below, there could be active pipes, and if lava moves up, that's the closest point to the center of the Earth, or to depth, you see what I'm saying? So it can blast out, and that's why craters often have multiple eruptions. Sometimes what happens, the magma starts pushing up. Mount St. Helens, they actually measured the side of the volcano before it erupted, bulging a couple meters. So this huge side of the volcano just coming up, moving up like that. And that's like the oh shit moment of science, like we better get our ass out of here.
Was that a technical term? The oh shit moment of science?
Pack up your bags and move as you go through. Relative to activity too, very unstable. You can see these are landslides along the side. The ash deposits are constantly being eroded and cut down through. Also notice that this was probably not always an active volcano. These are level layers of lava. Something came through here and blasted them out. You have some flows, a little more activity. This is probably where a lot of the fracture, and I believe that's the direction the fractures go. Anybody know why I believe that's the direction of fractures and folding in the side of the volcano? What else do you see over there in addition to landslide deposits? Lots of yellow. That's the fumaroles, or the gases that probably came through those fractures as it was degassing. And you see hydrothermal alteration. So there's probably lots of magma coming into that side of the volcano, whereas this one was more stable. Let's see if I find some quick numbers for you.